Yeah.
I missed your great introduction, but that was
Yeah, well, that's all right. We can give it a brief recap of that introduction since they missed it. We're going to be talking about work holding today, something different because we don't usually have a topic. We just usually talk about whatever's on our mind. But for those guys who are new to CNC routers, sometimes you need a way to hold you always need a way to hold your project on the table so it's secure while you're working. And we'll talk about the different ways and hope you enjoy that. Welcome, Wayne. Good to see you.
he's muted.
That's fine. I just saying hey.
Oh, oh,
Hey, guys.
Yeah.
all right.
So, Mike, you had something that you wanted to
Yeah,
show us.
I'm gonna talk about. Let's see. I'm gonna do this. Let me open this up, and then I will share. I'll go back and do it again. Share. Okay, here we go. All right, so we're going to talk about work holding, and you're looking at a plasma, but actually you're not. So,
As soon as you hit the share button, and
if I hit the share button, now you're looking at a plasma.
yeah.
Okay, and the reason I did that, I started here.
I can see what your problem is straight away there, Mike. There's a big hole in the middle of your router there that stuff falls through.
That's the problem, Ned. See that? There's the problem.
And we're quick here in Australia.
Yeah.
Exactly.
But Mike,
actually,
before Mike gets
go ahead.
Mike has one of the coolest router tables out there because it has identity problems. It sometimes identifies as a plasma table, sometimes it identifies as a router, sometimes it identifies as laser. You name it. It's all there.
I think his whole workshop has an identity problem. Everything transforms into something else.
Yes.
Well, that's because I don't have space. Space is the limiting problem. The final frontier.
Mm-hmm.
But actually, as you can tell, Ned, there's a slat table. This began as a VLOX CNC router, right?
Okay.
And on purpose, because my last machine was a Torchmate, which started as a plasma cutter, and I had done the same thing in reverse. And I realized that plasma cutters aren't robust enough to be routers. They're just built too flimsy because there's no contact. They just float over the top. So anyway, when I started my second machine, I bought a router, and I took off the slat table. That was the first thing I did. I'll leave those other two pieces there just to set stuff on. And I'll talk about this work holding, but I'm going to get right into the router part. Underneath the slat table is a dual chamber water table. So there's a chamber on the top and the chamber on the bottom. The chamber on the bottom is full of water. You put air to it, and it moves the water up to the top, fills up the top table. I can plasma cut when I'm done, let the air out, and I'm okay. But I'm going to quickly get away from plasma. In case anybody wants more, I can talk about it at another thing. But you see how I even hold the work down when I'm plasma cutting, because you can see my engraver. I engrave and plasma cut. So the engraver makes contact. So I have to clamp the steel down to the slats so I can actually engrave it. But again, moving right along. Boom. Okay. There's the same machine. Now I've got a hydraulic lift table because I've got plates in my back and everything else. So this table stores normally underneath on this hydraulic lift table. And that's how I hold my work down. I don't use the slat table because I was always afraid of banging into clamps and doing all this kinds of stuff because I just get, I guess, call the word lazy when I'm setting things up. So in my old machine, I ran into clamps. I did this, I did that. So now I said vacuum table, and that was it. So the vacuum table kind of easily slides right out, goes onto the hydraulic lift, and goes back underneath. Now from here, you can also see the bottom tank, this big black thing, the bottom tank of the dual chamber water table. This brass thing in the front is the vacuum manifold that distributes it to all the sections of the vacuum table so I can shut off what I'm not using, right? And in the very top, you'll see the bottom of the vacuum motor. In fact, there it is right there. So the vacuum motor is right there for the vacuum table, and it runs through and connects. So that's how I hold down my work. And actually, you can see me it's either taking it out or putting it back. Yeah, taking it out. And there's the vacuum table. I got this vacuum table from Germany, and it's really a good quality. There was a place in the US called Clamp U Systems that sold vacuum tables. And I bought my first vacuum table from him from my other machine. It was much smaller. And it worked really well, but it was a ton of money. So I found out it was made in Germany. I went straight to the manufacturer, had it shipped to me that way. And they made it to the size I needed. So it fits right over my machine. And now you can see the machine with the table underneath. And that's how I hold my my work down. That's a little bit better shot of the dual chamber water table. And I'll get through. Okay, and there's a close-up of the plasma and the engraver. And I think the next one is going to be, no, I'm back to here. All right, so I'm going to stop sharing. I'm going to open up another thing. And I'll show you how I do the same thing in the same machine with the fourth axis. Let me just, okay, here we go. All right, and I'll share again, and then I'll stop because I'm kind of going really fast. I don't want to take up too much of everybody's time. But so that was the vacuum table. And if anybody had any questions about it, I'd be happy to answer. But I find it really works well for me. I can do small parts, big parts, and I just drop them down, turn the vacuum on, and off I go. Okay. Now this, when I need my fourth axis, the advantage I gained by creating the dual chamber water table is I used to have about 4-inch clearance between the top of the slats and the top of the router. So I could only turn a very small part, you know, like a spindle or something. But I'm like, I want to do bigger stuff. So I'm like, well, dual chamber water table drops down underneath the machine, and it's steel and it's mounted rigidly. So I can make a removable holder for my fourth axis, right? So that's what this is. This is called a self-centering slide. And I bought this. There's a place that makes these. If anybody wants to know, I can find the link and send it to you. And so what happens is, here I was using SketchUp to draw the self-centering slide into the dual chamber water table. So just some quick views. And then I took the parts that were with my normal fourth axis and I mounted them on top. So now by turning that handle, which I had at 90 degrees, because I can't have it in the tank, I can adjust the length of what I want to put in there and just machine it. I went a little further. I'll show you. This is just all the things. This is what I had before. And you see, I really didn't have much room between the top of the slat table and the fourth axis. It was really, really small. But you can see how much I gained by dropping it down. Then I made these. I'm like, okay, well, I'm going to mount different kinds of work. So I used a hardened insert. This is hardened, and this isn't, right? So the center button is hardened. And I basically can put different size pieces on the work that I'm holding. And the reason they're different sizes in case I want the router to come across and not worry about hitting any of these plates. So if it's a small piece, I put a small plate, larger piece, I put a larger plate. And I basically screw it in with sheetrock screws. That's what this is made for. Just grab the wood with sheetrock screws and hold it. I think there's a picture of it. So let me, yeah, there we go. Okay, you can see how that would go in there. So you grab one in the chuck and the other one goes in the center, the live center. There's the self-centering slide. Back to this picture, just showing some stuff here. I'll skip over. Taking some measurements. Let me get to, okay, there we go. So now this whole thing drops into the dual chamber water table, and I can, like you see, crank it out. And what happens is, if you see the hole here, do you see my mouse moving when I point to these things?
I don't think so.
Okay, well, all right, by the
Oh, wait,
handle.
now we do. Yes. Okay.
Yeah.
Yeah.
All right, so by the handle, you see this little countersunk screw hole here. There's two more here, and there's actually two in the back. So with 6 Allen head screws, I welded some plates onto the top of the dual chamber water table. So with 6 screws, I can screw that down, and then I'm ready to go. Hold on just 1 second, guys. 1 second.
For those of you that are listening at home, Mike is probably one of the most talented manufacturer, people who fabricates their own stuff out there. So he's
I
back.
don't know about. I don't know if talented is the right word. I think extravagant might
Crazy.
be.
Well, like I said, Ned, honestly, desperation is the best motivation, and space is my limitation. I don't have it.
Yeah.
And
Mike,
I
you
am.
got more CNC per square inch than most people.
exactly.
Mike, don't get me wrong. I'm not having a good go at you. I actually do love looking at your workshop, the ingenuity that went into a lot of the things that you've done. You are far ahead of a lot of home inventors, engineers, etc. Yeah, no, yeah, it's. I just sort of shake my head in sort of like the level that you have gone to. That's pretty much it. Yeah, and it's not out of disrespect. Just yeah. So
No. I get it. It's like I said, but the only reason I did all this craziness is I wanted all these machines. I wanted a plasma. I wanted an engraver. I wanted a router. I wanted, well, I can't have 4 machines. I could barely fit this one in there. There's literally no room. But you can see how when I drop it in, and you with this, you get a good look at the dual chamber water table. Any of you guys got a router and you want a plasma, it's not hard to switch over. It's harder to go the other way from a plasma to a router. Like I said, they're not built heavy enough, but the routers are. So you see it as goes. But I'll flip through these. You can see how everything's mounted in there. That's how I lift the thing out and put it down, because I've got I'm figuring the whole thing out there. Okay, now you can see the plates I welded on the bottom here, so that you can bolt this down.
I do have one question for you
Sure.
though. Is why did you go with the self-centering type setup over just sort of having the chuck on one end and like still having those slide rails, etc. But like, why was the need to have it self-centering? My view is that if you've got a different length of timber and you're zeroing on, say, at the chuck where the timber starts, it will always pretty much start there. If you self-center it and you change size of the timber, it'll sort of like change your 0 point, etc., unless you're doing it from the middle or something. But yeah, that was my question.
Yeah, I'll tell you why. Honestly, Ned, when I was looking for, so take this 90-degree handle off and take the screw out of the middle, right?
Yep.
Basically, what I got is a slide, and then you see these little black handles with the red clamps. That's what locks it in place.
Yeah.
So when I was looking to buy the components or have something made or whatever, I found this company that made these self-centering slides in the U.S. Little 4 or 5 guys in the shop, and they gave me an excellent price. I couldn't buy the components for what they made the slide for.
I don't disagree with that, but if you had exactly the same thing, but without that 90-degree crank handle and the screw through the center, but you still had those little clamps and you just manually adjusted it to the length of your wooden tightened, and how come you didn't go with that? Why did you choose the self-centering aspect of it?
Like I said, price, and it just was ease of use. I could just take the part, if the part was this big or this big, I just turn the handle, it would go down, clamp it in, lock the stuff, and boom, I was, quick and easy setup. And like I said, couldn't beat the price. I forget what it was, but it was, I could look it up and I'll have it ready for the next meeting. It was really cheap and easy. So I was like, wow, okay, I'll do it. And the problem I had was, when they first saw it, the handle was obviously straight out. So I couldn't have the handle to dial it. So I said to him, can you give me the slide without the handle? And he said, oh, I'll just 90-degree it for you. I'm like, okay, no problem.
Fair enough.
Yeah.
Hmm.
So it was really good. I was excited about it. This is just the whole thing because the dual chamber water table is covered in truck bed liner.
I was
So
actually just about to ask, what have you got that covered in?
yeah, truck bed liner. And why do I do that? People do different things. They paint it, they this, they that. When the thing gets full of hot metal, it sticks to the truck bed liner, right? And if you didn't have truck bed liner, it would stick to the metal and you'd have to chisel it off and all this crap. So when I'm ready to clean this, which I do like once a year, I take a chisel, I scrape the truck bed liner off and everything just falls off and the metal underneath is brand new as the day I put it down. And if
Okay.
you see it now, it's filled with rusty, crappy, looks like buckshot from all the plasma that fills up and sits in the water and rusts and oh, it's nasty. Makes the cleanup real easy.
How do you go with the external parts of your CNC? Because look, I have thought about incorporating the two, and I have seen another guy build a full-size table. Actually, I think he built it so half of it was CNC and the router, and the other half was plasma. But how do you go with splatter and stuff like that on the external, like yeah, because aluminium would be fairly susceptible to those little weld splatters sticking to it and things like that.
I don't have a problem. I have some things. I don't know if I have pictures of them handy, but where I've used funnels and stuff. Let me see if I can get something here. If I have oh, triple edge finder. There we go.
I know a guy that makes those. If you like them,
Yeah, I don't like him, man. Oh man, what a pain in the. Oh, I'm sorry.
I have heard he's a bit hard to deal with. Yeah.
Yeah,
Yeah. Never shows up on Wednesdays at 7.
yeah, I love the triple edge. I tell you, I love my triple edge finder. Here, before I figured out how to do it, because I had a couple of triple edge finders, I actually cut this one, and then I realized I didn't have to cut it, but I still have that one, and I have my other one too. But
I
I was
was
in a
about to
hurry.
say that. I was about to say, is that one of his new designs? Is it like?
No, yeah. And then to make the thing easy to clean, this is actually the shower pan liner when you're doing the shower pan where you glue it together.
Yeah.
So I bought the shower pan liner, I glued it to fit the machine, and all the dust goes in there instead of going down into my water table. And when I'm done, I can just pick this whole thing up, take it outside, dump it in a barrel, take it, fold it up, and put it away. So it keeps the sawdust because it fills up with sawdust, even with the dust collector and everything. It throws shit everywhere. So it was quick and easy to make.
Okay.
Work holding.
It's amazing stuff.
All right, so I'm gonna stop sharing. I don't think I had anything else that I was gonna talk about. Let's see. I had the laser, 4th axis. I did that. Dual chamber water table. Okay, I'll do a quick one, just one more. This isn't the work holding, but it has to do with being. Oh, here it does answer your question, Ned, about the other stuff. So hold on one second. Let me share one more time. Okay, wait. Share. Where's the share button? Okay, here we go. Okay, now you asked how you keep splatter. I used one of these. It's like a funnel, one of those collapsible funnels. I saw this on one of the right? And that does
the silicon jobs. Yep.
Yeah. This thing really does keep the splatter down and it gets out of the way and whatever. But I didn't have it for the first year or two, and it wasn't the problem for me. But that's how I did it. And this is, now you can see these are the two heads. This is the plasma. There's the breakaway mount for the plasma and the engraver. And then here's the router and the JTech laser. So they both, cut and engrave, cut and engrave. So it was not hard. And this is simply, how do I get the stuff on and off? It's like fixturing. I have precision pin holes, right? And I'm sorry, 4 screw holes. I'm not lying. These are 4, I think they're 1/4 20 screw holes. And these are two precision fixturing pins. There's the male and the female. You buy them at any fixturing, any place that makes, you know, pins and tools and it's used on a CNC machine. And that's the head. You know, it's got that universal plate on it. And you just pop the, let me see if I can, yeah, you can see it from, no, wait, where is it? There it is. And here's the pins from the back here. You got two, it just drops in, 4 screws, done. It's a plasma. Pull it off, 4 screws, the other one on, 4 screws. It's a router.
Mike, zoom in on the pins if you could. There you
Yeah,
go.
here we go. They're fixturing. They're hardened, like bullet type fixturing pins. And the other part, if I jump back to it, let me just quickly jump back to the other thing, fixture plate. Okay, you see these are meant to just slide right in. It's like bloop, they just pop in, and it's always perfectly aligned. So that's the quick change aspect of this. And if anybody, like I said, is interested in anything like this, I'd be happy to share it. There, here you go. Here you go. This was a description. Somebody asked about it, and I said, yeah, female, male. Pop it together.
Yep, and it's always in tram.
And it's always, yeah, it's always, you don't have to do anything. Let me see if I got anything else. No, that was that. And so I'll shut up now and see if somebody else wants to talk.
Sorry, I'm joining late. Is that pneumatic? Is it like the Shunk Vero system?
You're talking about, okay, I'll pop it back up a second. Hold on. Change the axis. Here it is. Okay, so to answer that question, I'll go to this picture. Give me a second. Here we go. And then I'll share again. The way that I did this is because I wanted it to be universal. So the Z-axis is obviously, these are, all I did to make this was take 2 Z-axes and I put them at 90 degrees, you know? So one holds the plasma and one holds the engraver. Now in this case, since the plasma never contacts the part, it doesn't have to be rigid, but the engraver, if you notice here, I've got like side supports and I really stiffened up the engraver. That's the one that mounts to the machine. So the engraver is straight down from the machine. So when it's engraving, it doesn't move around or lose its position. The plasma never touches. And the engraver, to answer that question, is pneumatic. You see the pneumatic cylinder. It's just up and down. Boom, 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 you know? It just
could you make that sound again, Mike?
Yeah, yeah.
just checking.
And then it's the same for the router. This is on the screw, but in this case, it's the opposite. Now the router is mounted to the machine and the laser Z-axis is at 90 degrees and it's on a cylinder and it doesn't make any noise. And this is just a JTech laser that I probably have some pictures. Yeah, I made this holder for all the JTech controls on my plasma cutter. And instead of having wires running everywhere, I mount the whole JTech mechanism right in that box next to the laser. So it all travels with the machine. So I don't have to, you know, it's quick and easy. And the laser, when I'm not using it, since it's magnetic, I can pull it off and twist it around, point it up and cover it. So it doesn't get, you know, sawdust all over it and crap. Did I answer the question?
Yep.
Okay.
Yes.
Okay. Yeah, I try to talk fast because I don't want to monopolize the meeting. So.
Well, you also said you had to go in a few minutes. So.
Yeah, well, that's true too. But I didn't want to monopolize the meeting, so I figured I'd show what I got and then step away and listen to what you guys got.
Very cool. Any questions for Mike on any of that? I'm checking the Facebook feed to see if anybody's watching live. And
while you're checking, Bill, here I'll do this. This is a little bit more about the JTech laser. This is the mount for that.
Yeah, I cannot tell.
So that was my first test. Not a good one because I couldn't figure out how to turn the laser off at the end, but I did resolve that problem. Yeah, now you can see the laser flipped upside down. So it's out of the way and it put a little cover on it and it doesn't get all filled with crap. Yeah. All right.
For those that are interested, if you one of my first attempts at mounting a laser on a CNC to turn it on and off, what I did was I put a micro switch at the bottom of the Z-axis. So what I when the CNC was at zero or positive, the laser would be off. But as soon as it hit like -1, the laser would come on. So as you lowered it to and this was only a very small little 1.5 watt laser that I used initially to, I used it to color the wood to do various levels of burning. And by lifting the laser up an extra 0.5 millimeter or millimeter, you'd put the laser out of focus. So you'd get a wider, lighter burn onto the timber. And the simple way of controlling it was just a straight 5-volt feed, no PWM. And yeah, when it cuts to the bottom cutting depth, which you'd set in your CNC that cut down to -1 or 1 millimeter, the laser would come on, and then as soon as it lifts up, the laser is off. So that was a very simple way of controlling a simple laser to color in wood or to apply tones to a piece of wood.
That's a good idea. I like that idea.
Well, very cool. So some of the members in our CNC community have posted stuff over a number of years that we've been around, and some of it is pretty ingenious. And you know, if you don't mind, I'll share a bit.
Yeah.
But I'm
Go
gonna
ahead.
start. I'm gonna start with something that well, hang on just a second. This might take a second. Let's see. Keep using this ad. Open. There we go. Yeah, my computer decided to be rebellious just now. So when I started building my CNC router, I used a method of hold down that a lot of folks use. I use T-tracks. These aluminum bars along the bottom right in front of this laser level are 80-20. 80-20 makes all the aluminum that you see on this machine. This is back before I had an aluminum machine, by the way, all aluminum. The 80-20 has got a single slot, and it takes T-nuts, economy T-nuts in there. And I put a few slots around on the table, and I was able to make my own clamps and clamp my wood down to that. And you see these were different sizes because I didn't know what size wood I was using, and I didn't want to be limited to using one specific area of the table all the time, and then having my machine wear out unevenly. So I varied the lengths of the T-track. Not sure I'd do it again, but that's what I did. And I also had horizontal and vertical T-tracks on it when I got started. So then after that, you know, there's several examples. Here's another guy that let's see if this will work here. Yeah, I'm getting ahead of myself. There, went the wrong way. There we go. There's another member. You can see the economy T-track down in the hole, threaded quarter 20 bolt. He made his own clamps. Those look like maybe oak. It doesn't matter whatever wood that is, and some plywood spacers. And he'd put varying thickness blocks to hold it, you know, and clamp it down. This is probably one of the most common methods that people use. Wooden clamps are great because if you screw up and the router bit decides to cut where the clamps are, everything's fine. You're not breaking anything because you're just cutting through more wood. So that's a cool cool feature. Some of the other things that I developed that I'm showing you the ones that I use personally. Now you can see this table has seen better days from all the cutting into it and everything, the spoil board. And one day I'll get around to changing it out, but I flatten it every now and then. Anyway, this was a toggle clamp, and there's a fellow down in New Zealand who developed this. And it's basically a piece of MDF with a notch cut into it, and this head or lever, if you will, is cut eccentrically. So as it is moved from one side to the other, it pushes up further or releases lower, depending on which direction it's going. And there's a thin piece of wood attached to the front of that. And that piece of wood deforms and gets the clamping. The second part of this fixture is this L-shaped bracket. This allowed me to use different size pieces of wood, but this was a project that used the same size piece. And so once I got this set by sliding the L bracket up and down, I was set, and I just unlock it or lock it, change out the piece, put it in a new piece, and off I go. So these little nuts I made out of PVC, and thread capped them for 1/4 20, and used little pieces of all thread into the going into the T-nuts, and that's how I did it. So it was quick on to the table, quick off the table. And I used my triple edge finder upside down. I don't have a triple edge finder in here to show you what I'm talking about, but there's a raised surface on the top of the triple edge finder, which will let you probe an inside corner. And that's what I would do. I'd flip it upside down, put it in the corner, set my X and Y, and then I would set the Z also with the edge finder upside down on top of this white piece of wood or white piece of plastic. And I'd probe down to the bottom surface of the triple edge finder, because it's the same distance from the top of the triple edge finder to the bottom. It just depends on which orientation you have it. And so it knew where the Z axis was, and everything was fine. So, quick setup, and quick change. So, that was one of the forms of work holding I was using. Let's see.
That's a nice setup, Bill.
Yeah, thank you. Anything else for me? There were a lot of them here, and I'm gonna go through some of them if you don't mind. This is a portable vacuum table that somebody designed. And I apologize to any of the members inside of the forum. I did not make note of who each of these projects belong to, but I thought they were cool and I would share them. So he made a portable vacuum table. You can see the plenum here that he created. He's just plugging his shop vac into it to hold down his parts. Oop, I went too far.
I've actually seen that one. I've seen that one online. Someone that one there, yeah.
Yeah.
Whether it's the original designer or someone that's actually copied him.
Mm-hmm.
Yeah, so I've seen that design online.
What I like about this table setup that he has as well is he has notches cut into his spoil board at particular intervals, which allow him to use the squeeze clamps. I don't know what the proper term of them, speed clamps, I think they call them, to hold this board on the table so he can get his setup on there. It's going to be fairly square, and do what he's got to do. And then when he's done, it's a very quick breakdown and to put it all away. He's a genius. I kudos to the guy who did this. I don't have have the information on a lot of these. There's another guy who's using a vacuum hold down setup on just a portion of his table. So each, he's got 3 sections here that he can do things with. He's also got pneumatic pins. So if you've got air in the shop and you want to always align your material to a specific place, you can use these pneumatic pins. They're not really expensive. They have them on Amazon. They have them a lot of places, and they're fairly inexpensive. And you just hook up some. He's got some down here at the bottom edge and some on the side, and slide the board in, and it's all the XYZ can be saved in that corner. Another hold down real quick. Some guy made metal clamps that he's using. And this is a close-up of one of them to hold parts when he's doing his luthier work. Pretty ingenious. I hadn't seen those clamps, and I'd like to know where he got them, because they're pretty low profile and kind of cool. Let me see. Step blocks and toe clamps. Another way to do it. These are pretty cool.
Yeah.
These push the regular shaped board into place, and this one here, and this one, yeah, you can't see my finger, can you? The one on the bottom and the one on the side set the X and Z for them, in place, and all the others are just there to hold it onto the work surface. So pretty cool.
Nice.
Now, this guy got some really advanced hold downs. Robotic hand, no. This is just from a project he was making. But anyway, that would be the ultimate hold down, probably. Here's an example of somebody who's using tabs to hold the parts into onto the sheet. You can see them in the bottom corner here. That's a tabs all around, so that he can cut a full sheet without worrying about pieces coming loose and being destroyed. And he's holding them with some more step blocks. Here's I'm really buzzing through these because there's a bunch of them, and I'll probably stop before I finish them all. Let you guys talk. But this particular spoil board has threaded holes at certain intervals that allow him to clamp things, and he's also got a guide ruler down in the corner that makes sure that his pieces are always straight when he puts them on the table, despite the fact that this is at a 45-degree angle. Okay, yeah. This is a pallet plate that somebody created because he wanted to make a whole bunch of the same parts, and he wanted to use painter's tape to do it, to hold it down. So, you get your painter's tape, you put one surface down, you put some CA glue on the tape, and then you put another layer of tape on top of that has been attached to your work surface, and that is a really strong bond. And you can see the painter's tape. Let me try that again. You can see the painter's tape showing up inside of the kerf there. That's a very strong way to hold a part in place while you're machining it. I've done this on my Tormach mill as well, using flood coolant, and it holds up. So pretty cool method of work holding.
The biggest thing to watch for with that is heat buildup when you're doing metal.
Yeah. A lot of you have vacuum tables. This is a, what do they call it? A rotary vane vacuum motor, I believe.
Yep.
So that's what they look like. That's what you're looking for when you're on Alibaba or whatever, looking for one.
Eligible groceries, utilities, rent, and over-the-counter items. So if you have
Somebody's sound is up. This was a pretty cool vacuum bed for an unusual shaped project.
Dual eligible special needs plan. So call now. Humana, a more human-like healthcare.
Somebody's got an ad going in the background. Vacuum pucks. You can put down a bunch of these and they actually suck down to your spoil board and to your part if they're working right. Here's another vacuum table. Somebody else using painter's tape.
Last night, the Kennedy on Jane.
Oh, this one was interesting.
Has come through, and she will now leave to serve a 3 to 5 year sentence.
Let me see who I need to mute.
Could be Wayne. Wayne's not at his desk.
Okay,
No, I think it's
Laying back next to each other, dude.
well, it was
Michael Chapman.
okay. There we go. This was a fixture a guy made for laser cutting and engraving the names on these Harley Davidson or similar designed flags. He's got these bolts going into a bottom plate, and all of these are the same size, and so he stacks a bunch of them one on top of the other. Sets his laser height, lasers it, sets his laser height, lasers it, sets his laser height, lasers it, you know, and he removes them, and you can see in this picture, you know, how many different ones he has, and you know how he's using it. That makes sense to everybody?
yes. Yep.
This is one I did. This was one of the things we did for a job. You can't really tell it from this angle, but these white vent covers are at a 45-degree angle to the bed of the table. The sides of this piece were machined in such a way that they held it there. And there's toggle clamps that held the piece in place, and you slide it all the way to the right, or excuse me, to the left, and that's up against the stop, and you know that's how you set zero. And there was a spot machined flat on the top of this thing where we set the Z height. And so when we wanted to cut these vents, we actually cut from the back side. So the bottom side that you see is the back of this fixture. And we had the ample clearance for the spindle to get in from the back, and it would plunge down and cut and raise up and plunge down and cut at these 45-degree angles to give us, you know, 45-degree angle.
See you later, Michael.
Yeah. Bye, Mike. So anyway, combination of both T-track and vacuum. Here's some more step clamps, an advanced vacuum table out of aluminum. This was on a Unsrud machine. Craig Jig makes these pretty cool clamps. Anything else here? And the professional machines have what they call vacuum pods. This is a Yessi Rover, I think. And it has rows of these bars, these the darker sections that you see standing there with the hoses coming out of them. You could slide them anywhere you needed them on the table, and there are several pods along it, which each have vacuum, and you can control them all. Anyway, that's all I have for now.
I wanted to show just how primitive a vacuum you can get away with. If I could do a screen share.
Sure, just hit the button.
Let's see. So back in like 2006 or so, somebody said, if you want to try vacuum, just drill a hole in your spoil board and hook up a shop vac to it and see if it holds anything. And so literally this is a hole connected up to a shop vac. We've got some all-star gasket that we used, and the way we'd do it is if we had a piece that was whatever size, we'd put gasketing around there, and then we'd put in some support so you don't get the piece sucking down in the middle.
Mhm.
And we actually used just the shop vac and all-star gasket for about 5 years. And here you also see I am using a vacuum pod, but something just this primitive was surprisingly quick and effective for us. So you don't have to overthink vacuum.
There was, as long as we're on vacuum for a second, there was two more in this list that I would like to show. That just blew me away. One of the guys, I think this was Imad Hassan from the group. I met, it's spelled IMED, and I'm sure I'm screwing up the pronunciation. Hassan. He came up with this 90-degree rotational, or 180, excuse me, fixture that he can tilt this thing either to the left or right to machine on the side of something. And it's really quite a simple setup and very effective. And I'm going to make something just like it, because I had the need for something like this when I'm engraving the triple edge finders. But I thought this was pretty cool. He's got this on his on a like a workmate sawhorse beside his CNC, and he's able to do whatever it was that he needed to do really quickly in this fixture. I thought this was genius, and I like it. I want one. And there's a company on eBay who sells these little vacuum pods out of aluminum. They weren't expensive. I think this was less than $100. And I think this one was Venturi, had a Venturi vacuum generator. So anyway, those were the two that I forgot to show.
Question. What kind of materials can you get away with in making your own little vacuum pods like the aluminum one we've just seen? Would something like MDF work, or is that too
No, you
porous?
need something that's non-porous. So
Okay.
I made mine out of HDPE, high density polyethylene.
Yeah.
That stuff works really good.
Even a dollar store cutting board if it's deep enough, I imagine.
Yep.
Cool. Thank you.
Yeah, the material Imad used was starboard, I believe.
I fought the vacuum for a long time with the MDF and all, and I didn't want to spend my time brushing in all of the little grooves and tried the HDPE, and I finally just bit the bullet, made a phenolic table. I have two of the Lighthouse motors under my shop so that the noise stays down, and I can suck on that. And with the phenolic, it is so much better than anything I have had. And because I can drill a hole anywhere I want and tap it, I have fixtures, I can put locating pins, and as long as I keep track of them, I have a file and I keep track of where those holes are. And the guy at All Store kind of convinced me of that kind of thing, because he was saying, if you're not using, like a $3,000 regenerative blower, you don't have that much vacuum. And if you do MDF or something, you're losing a lot of the little vacuum you have. And for a vacuum jig, like you were talking, whether you use MDF or whatever, I have made those out of phenolic. It's not the cheapest stuff around, but it's completely non-porous, and you can, it's easy to machine, and it's really a good material for those kinds of things. And I've never tried to do aluminum. I have a shop bot I bought in 2001, and I've recently put a Centroid controller on it, so it's pretty upgraded. But the phenolic, I think, is the way to go on all of that stuff.
Very cool. Thank you. I love the mention of being able to tap it. That's another
Here-
level.
Here's just a sample from a quick Google search for phenolic plastic sheet. So there you go.
I have, there's also, if you have a vacuum table, I have a grid on my table. All-Star has, in the last year or so, they sell a gasketing material. I think it comes 2x2, and it has a series of 1/4-inch holes. And I have it mounted on a 2x4 piece of MDF. I can throw it on my vacuum table, and I can throw a pretty small piece anywhere on there, and it'll suck through without doing anything to block off the vacuum. It's really a terrific product. But you have to have, it was like the thing that I think Michael showed from Germany, where it had all the little holes in it. And for just holding stuff down. But in all honesty, a lot of what I do, I have a 2x4 piece of plywood that I can put down on top of my table, screw it down, and then I screw onto it, because I don't do a lot of repetitive things. So I need to be able to move and get things.
For anyone that's interested, if you go to my YouTube channel, I did a interview with the one of the principals at All-Star, and he talks in great depth about his product and how to use it. And I'll grab a link and put that up for you guys to check out. Let's see.
If no one else has something, I could start a presentation of my own.
Certainly.
Okay. All right, well, here we go. Hello, everyone.
Ready?
It's my CNC behind me. You got the Axiom 36-inch basic. It has the T-tracks integrated, and so these are what I basically started with. Just your standard wood clamps, and completely agree with Bill that wood is far superior in that they won't destroy your bits. I've actually got a picture, if I can find it really quickly, of the extent of the damage on one of them. One sec. Yeah, so it does get pretty brutal. And it just keeps on rolling. From there, I have experimented with a bunch of other means. One of them is this kind of toothy gripper from the sides. This helps me surface thick boards, and it's been quite effective. They're just screwed to a piece of plywood, and with some with the very same clamps that I had earlier shown, I put some effort into pushing them together, and that applies just enough pressure to hold the board. There's even a video that I'd made. No, I can't find that one. Next up is, these are some custom 3D printed T-nuts that I'd made that fit the machine just right, because I tried to do some Amazon shopping, some AliExpress shopping, but I couldn't find T-nuts that fit perfectly, so I opted to just make my own.
Just do a search for 8020 and they'll have them there.
I see. Okay. Well,
With
It's
the
8020.
with T-nuts, they don't have to fill the entire slot. They just need to be able to be pulled up against the bottom edge of the top, and they are actually the ones from 8020 anyway. The center where you tighten the bolt in are actually designed to be a good fit from side to side in their tracks, so it self-aligns once it gets tight.
yes.
And the other benefit you get is you don't have to slide them in from the end. They're designed to drop it, like there's a number of T-nuts that are designed to drop in through the center, and as you tighten it, they actually sort of rotate a little bit, and then as they tighten, they'll then pull up, and they do the same thing to come undone, and you can actually pull them in. So if you've got a couple of things on the hold down table and there's just a little gap, you can just squeeze one into the side there.
Cool. Yeah, I have seen those. I didn't know they existed in my specific size. Thank you. I will check those out.
Very cool.
Yeah. Here is something I call the long jig, and this helps me do what's called tiling, because I often need 48-inch long jobs on my 36-inch long CNC. So I came up with these kind of hold downs that help me again clamp lumber from the sides, and it again 3D printed, so
that's genius.
Thank you. 2 spikes to just kind of bite into one side, and then on the other side is these 2 screws that are slightly tilted downward, and they apply quite a monstrous amount of pressure.
Yep.
And these slide from side to side on some just your basic dovetails cut into some what's this called, melamine, and that's worked quite faithfully over the last couple of years. There's another shot of the basic clamps, and then I also have some videos. So before I get to the video, sorry. Next screen share is gonna be this, which I call the big jig, and it is a parts holder.
Zoom in on that if you would.
Yeah, sure.
There we go. Thank you.
This is a slightly smaller parts holder, registered to the bed of the machine, and the geometry is saved in an Adobe Illustrator file. So the 0, 0 of X and Y is saved and infinitely repeatable. And it just uses a wedge to hold it down. And it has been quite effective. I've since upgraded to I don't know what to call it, a multiple parts holding. But here's the very first version. It was registered to the bed with copper pipes and a cam clamp. Finally, the video.
I just remember the fellow from New Zealand's name. It's Pesuelo, Peter Pesuelo, I believe. He had a website called CNC Nuts. Anyway, go ahead.
Sounds appropriate.
Yeah.
Just a small example of that side holding, as I made some custom shaped pieces.
Very sweet.
Thank you very much.
Actually, those swords make good money. I was at a medieval
Yeah.
fair not too long ago, and they were selling like hotcakes to kids.
Mhm.
Like, ah,
Yes, no doubt. So yeah, that's what I got. Welcome to my TED Talk. Thanks for watching.
You're welcome.
aren't you supposed to do a bit of a dance for us if it's a TikTok thing?
No,
Oh,
no,
TED
no. He
Talk.
said TED Talk, but
Oh, TED.
just for those folks from TED Talks, which is a very great service, we have no affiliation. No, no, nor do we claim any copyrights. They're all TED Talks stuff, so it's very cool.
Oh.
Now our lawyers are satisfied if I could afford one. But what did you send here, Ned, in the chat?
I just thought I added some of my, like I have shown those vacuum clamps. I thought I'll let everyone else speak. As Michael said earlier, I didn't want to hog the hog the camera or the limelight, but I thought I'd include some pictures for you of my vacuum hold down fixtures or plates, if you prefer to call it. And I've also included a set of my designed cam clamps and the DXF files for them. Basically, they're really great for just holding down onto a wooden spoil board for flat bits of wood, etc.
Oh, there we have your first photo.
Yeah. So look, what my experiences with vacuum hold down is everyone seems to think that vacuum hold down is sort of like a universal thing, and that whatever it is that is going to be the bee's knees that's going to fix everything. With those large vane type vacuum pumps that you displayed, they are quite expensive. And when you see CNC machines, they provide you, like when you see them on sale, particularly the larger machines for the 4-foot or the or larger tables, they sort of picture them with one of those vacuum hold down machines, and they sort of give you the impression that you can hold down a sheet through and use another piece of MDF. And what that means is that you're actually pulling vacuum through the MDF sheet, and it holds another sheet on top. And it does do that, but it will slip if it's not right, etc. And generally, to do a 4-foot sheet, sorry, a 4-foot by
8 foot.
I'm metric, so whatever the full size sheet, whatever it comes out to be, sort of thing, the 24 by 1200. You actually need at least 2 vacuum pumps to hold those down properly for it not to move, particularly if it's got smaller parts on it. So if you're doing large cabinets and the panels are large, you need less vacuum. But if the items are small, or if you don't want to use tabs, you need a lot of vacuum to hold down small parts. Another problem is if you cut a little puck or a circle out of an item and you don't have enough vacuum, that could generally tend to fly across the room if you aren't holding it down properly. And one of the things particularly, so I actually, just to give people a bit of a background, because we've got a few new people here, is I work on large CNCs in industrial environments, and I also work on smaller CNCs at home for some hobby stuff and just a bit of fun sort of thing. And there is variance, and I think people need to get comfortable with using various types of hold downs. And one of my most popular hold downs is the old painter's tape with super glue. But the vacuum hold down tables are very good, and you don't need a lot of vacuum pressure to hold things down. What Bill's got popped up there at the moment is, do you want to go to the next picture for us, please, Bill?
Yep. Give me just a moment. It's not always easy when you do this, Ned. It's generally easier for me if you share yourself. But,
okay, well, I'll share it if you like.
I'll
share it. I'll share it.
Okay, because I have to open it in the viewer.
Okay. So I have to open it in the viewer, and then Okay, now I'll share that Zoom and share. And where is it? Which one is it? It's that one there. Okay, so this is the part here. So I'll explain what I'm holding down quickly, and then I'll explain the method or the idea behind the hold down table. These are HDPE, high density polyethylene liners for gate valves. Good money, by the way. So basically, these are double-sided. So there is a small amount of cutting on the other side that I don't have pictured there, but they need to be machined from the back and from the front. And there's a O-ring groove that goes in the center. So
You can zoom in to give them a better view as well.
Zoom. Where's the zoom? Oh, here we go. So yeah, so basically there is a couple of small strips on, there is a small amount of machining on the other side, but on this side you've got the O-ring groove and you've got the pocket in the middle and so on. So it is a two-sided operation. So going back to
it never changed, by the way, for us.
Oh, didn't it?
Nope.
Oh. Oh, look, there's not much to see. It's sort of like it's a two-sided operation. There's some machining on one side, then there's machining on the other side. So can you see are we back to the fixture plate yet, or is it still on the same photo? Oh, hang on, you know what it is? I know it because I was on full screen when I opened it last time. I'll just reshare it. Stop sharing. And why can't I get by there? Because it's up there. That's why. Okay. So share and okay. How's that look?
That's the first one.
Okay.
Yep.
Okay, it's now showing. Beautiful. Okay, so basically over here, you've got an O-ring groove, which I do a circular ramp in to that. And there's a bit of two-sided machining on the other side and the pocketing, etc., on the back half. So going back to the actual fixture plate, what we've got is when I start with a fresh sheet, that'll go straight onto that fixture plate. You'll see little pins. You'll see little pins on the corners. So how can I mark? Can you guys see my mouse at all when I'm doing that?
Yeah, we can see it.
Okay, so they're like little fixture pins, etc. And on the outsides here, there are fixture pins as well. So you can see on the outsides, you've got fixture pins, and that's to center. And just on the ends over here, you can see a fixture pin there and a fixture pin just there. So, and what those fixture pins are, if you have a look up on the top sheet, they're nothing more than the 6mm or 8mm nylon raw plugs, like what you use for screws in walls, etc., brick walls and so on. That way, if the CNC hits them, there's no damage. And the other thing that I use as locating pins is those little corrugated dowels that they use to join furniture together with. So basically, what happens in this one here, when I put a fresh sheet in, I located it with the outside pins, and it cuts the profile of the sheet, levels it, puts the two small pockets on the top. I actually machined the main part of it, which is all where you saw all the holes and everything with the center. Then I flip it over and then I do it from behind because there's a raised section. And when I do it from behind, I drop that piece that piece there in, and I'll just go back to the fixture plate. So what that piece does is it actually goes right up the center of that, and that locates the entire job onto the fixture plate, and then it holds it down. Then that allows me to cut the circle and do the O-rings and just finish. There's a raised section on the other side of that large circle there. So and I locate that using those two pins into those two holes on either side. The vacuum comes through the side of and what I use for the vacuum fixture plate is a piece of 10 or 12 millimeter polycarbonate. Now that was just scrap polycarbonate. We have places called like Reverse Garbage. They take industrial scrap that's still sort of usable. It could have been signage with vinyl stuck on it. It could have been whatever, and they sell it to arts and crafts people to make stuff. So if you've got some sort of Reverse Garbage, Craigslist, Marketplace, eBay, and if you go around some factories that do work with acrylic and so on, they will generally have scrap, and they will be happy for you to take it because they have to pay to get rid of it. So, and then you can repurpose it by machining it. So what I've done here is you've got the 6 millimeter EPDM rubber cord that we use as the gasket. I've drilled a hole through the side and used the zero insertion, like the air hose type fittings to come in from the side. And there's only one air hole that's right underneath the little zoom mouse pointer there that the vacuum comes through. And they're just some randomly grooves, like just to let the airflow. Vacuum will travel through the slightest of crevices. You don't need to do 6 millimeter tracks or 8 millimeter tracks or anything like that. So that will hold down the main piece. Then when I put this larger piece on, that will hold down onto that large EPDM, and it creates that stepped raised bit to hold the reverse side in a position, and it allows me to cut that center puck out and do the finishing processes, etc. And so the bottom vacuum holds that down once the part is on it, and it all just sandwiches together. Now, if you do something like this, I'm using a small rotary vane refrigeration vacuum pump. I've also used diaphragm vacuum pumps similar to the one that Milo has over his right shoulder in the background there, if it's still there on his bench. And when you use this type of setup for vacuum, you don't need to achieve minus 28 mercury to achieve a good vacuum. You'll get a really good vacuum even at 18, at minus 18, etc. So you don't need very high power vacuum when you use EPDM, and you don't have any vacuum loss, etc. It will hold down really, really well. The materials that you can use for the hold down fixture plates, as I'm using there, polycarbonate. And just to mention earlier, you can use MDF, but after you machine it, you'll need to cover it with something, whether it's some sort of cheap fence paint or something like that, because MDF is very porous and lets air through. But if you just need a quick vacuum fixture plate, that with some cheap paint on it, let it dry, and you're good to go. Pods are good. I generally find that the big vacuum tables are sort of useless unless you're in a commercial environment and you are cutting from sheets. The best thing to do is small fixture plates or the pods. So they're my experiences. The other hold down that I use the most is just simply screws into MDF. So I'll screw like a 20 or 25 mil MDF block onto that aluminium table. And another one that I use is I'll on that aluminium bed that you see underneath there. I have holes spaced. It's actually a weird space. I think it was 45 millimeters, 45 or 40 millimeters spaces. And that allows me to put 50 millimeter, 75 millimeter, or 100 millimeter flat aluminium flat bar. I can cut small squares, etc. And I just Allen bolt them straight down, and I machine my fixture plate into that for the parts that I hold. I do a lot of brass machining, so that sort of facilitates that really well. Yeah, I just found doing disposable hold down plates for smaller jobs like this, be it MDF or acrylic or basically any material that I can find that costs me the least amount of money as possible, I repurpose it. And that's pretty much it.
Awesome.
And I've included some hold down clamps. There's the DXF files. They're cam clamps, and the little pieces up the top I found to stop damaging your wood, or if what was it? I didn't get your name. I think it was the guy with N that was doing the last presentation.
Yeah.
Like how you had your screws, you could put a couple little screws or nails into that. But the idea is I find when you're holding down pine or something soft, the clamps produce that much force that it'll actually dent the material. So having those little pads with the curves cut into them stops it from sliding and creates just like a larger flat surface area, not to damage the job that you're holding down unless you're actually cutting it right out. And they're quick and easy and disposable. Basically, I pocket the center and I put a metal washer in there, so as that if you don't put a metal washer, it'll basically twist and curve, and they'll get damaged after a while. And I find the cam hold down clamps really well, but the most of the stuff I use is just hold down screws or painter's tape. So that's pretty much it.
Awesome, thank you.
Very cool.
There is one more application that I've used that hasn't been mentioned on Vacuum Table. You know, the vinyl sign material, where you cut out the vinyl and then off of the backer. I use the vacuum to hold that down to where it's flat, because most of this stuff comes in rolls and it's uneven. And a lot of the vacuum or the vinyl cutters keep it tight and down to a flat surface. Putting one of these vinyl cutting knives in your spindle with that vacuum, it now holds it down flat, cut out your lettering. Works very well.
Yeah.
Because of course the vinyl sign material is non-porous, so it sucks it down nice and flat.
Excellent. Excellent. Are you using for vinyl cutting, are you using something like a Cricut, or do you have an actual vinyl cutter, or are you doing it on your router with like a Donic knife?
I think he's replacing the Cricut with his CNC.
Oops.
Yeah. You can actually buy on AliExpress, you can actually buy the as long as you can hold an 8mm diameter tool, you can get the little ball bearing shaft with that will take the vinyl cutter knives. Yeah, so you can turn your CNC into a spring-loaded vinyl cutter really easy.
My apologies, guys. I locked up my computer here.
No.
I don't believe this. I was trying to do a good thing here and drag over a picture, but it's mad at me right now.
Yeah, these things happen.
Boy,
Try
it is very upset. Control Alt Delete Task Manager. I may be back here in a minute.
okay.
Hey, it finally loosened up again.
There you
Welcome
go.
back.
And let's go here. Let's get this over here a little further before I share it again. Wow. This is the second time today this thing has gotten angry. You can see this drag knife here?
Yep.
This knife is one of them from Widget Works. It's not cheap.
Yeah.
But it is built extremely well. This goes into a 1/4-inch collet. This knife is supported on each end with extremely small ball bearings. And they do a great job. There's a spring load in here, which you can't see on the end, is a set screw that applies enough. Well, that's how they control how deep it cuts through the vinyl.
Yeah.
If it's cutting a little too deep, you can back it off. The point of the knife is slightly off center so that it casters extremely sharp. This thing isn't the size of a lead pencil lead.
Yeah, I was gonna ask if it's offset, and so what is the offset? Because I've got the large Donek knife, the 1/4 inch deep one, and it's a real pain to try to figure out.
Yeah, this thing, let me turn up my speaker just a tad. This thing, I just entered it in as a very small end mill. The offset was negligible, and of the lettering that I've cut, I haven't had any issues whatsoever on corners. You know, the Donek knife is just way too big for that type of work on
Yes.
vinyl lettering. But tool for the job.
Awesome.
That one's even better than the ones that I found. The ones that I found, you needed minimum tool hole or collet size was 8 mm. So for the smaller machines, it was a bit of a pain. But yeah, now that you've got a 1/4 inch one, that's brilliant. I'll have to keep an eye out for that.
Yeah, they don't give them away, but
No.
they are engineered way better than I thought, because you do not want to open this up above a bunch of sawdust. The tiny, I was impressed that they actually had a normal type ball bearing on each end of this thing, or an open shaft ball bearing. Little tiny thing. If you had ever dropped it, you'd be done.
I've actually seen those ball bearings. I was watching a watchmaking video, and they use those really, really tiny. They can't be much more than 3 or 4 mm in diameter, but they use them on the escape mechanisms for the grandfather clock type mechanisms. And yeah, no, that's a good application to them. Yeah, they are small.
Yeah, I only tell you that because I almost goofed up. I came in on top of my bench. I laid out a cloth.
Another path that I've been interested in, sort of like having a go with the CNC, is the oscillating knives. And actually, I was just thinking you could apply it to any of these vinyl cutter knives. Is the tangential cutters. And you can easily apply that to a lot of CNC controllers, where the software will actually rotate the knife for you, so you can have a very precise knife spot on center. But with the oscillating cutters, you can do foam and styrofoam and all sorts of soft materials, cardboard. Make your own cardboard boxes.
Yeah, while my 4x8 CNC is just slight overkill for cutting vinyl letters, it prevents 2 machines.
Yes.
And for how little I do it, it was a reasonable cost for getting a pretty good result.
Well, my daughter has one of those Cricut cutters over there, so anytime I want to do some vinyl, it's just easier to outsource it. So
yeah, there you go. Then just keep calling her. Are you done yet?
Yeah. Well, no, it's a good excuse to go over and hang out while she's working on it. Yeah.
Yeah.
You can actually do a fair bit with the vinyl for those. I saw that you can even do things like t-shirt stencils or iron-on stencils, so you can iron them onto your t-shirt and stuff.
Yeah.
Like, yeah, some really great stuff you can do with those.
That's the kind of
confirm.
machine. Go ahead. I'm sorry.
No, it's okay. I was just gonna say, can confirm. I've made a graphic for my friend's new baby's onesie with the Cricut.
Yeah. That's the kind of machine that you keep an eye out for at the garage sale. They also call those tag sales in New England, and you know, all kinds of other names, I'm sure. What do they call it, that type of thing in New Zealand, or excuse me, in Australia? New Zealand on the mind.
I think it's cricket or circuit, or am I pronouncing it wrong? I think it's the same thing.
It's Cricut. I just meant, what do you call garage sales?
Oh, exactly what you just called it. Garage sale, swap meet, boot sale.
Yeah. Okay.
Yeah.
Just curious.
I've actually got a big car swap meet coming up this weekend up at Hawkesbury that I'm going to be heading over to.
Fantastic. So, anyone else have something that they'd like to share on the work holding subject or on any other subject? Just speak up. We're good tonight. I think we probably got enough ideas here tonight to fuel a lot of imaginations.
I kind of have one last one that I forgot to mention the first time around,
Sure.
and that is coming back to the standard clamp.
Hang
You
on,
can
I'm
flip
going
it
to change the view so that we can see just you. There we go.
Yep. So you can flip these over and you get the thick side, but most recently, this is probably my most recent update to my work holding is the slightly sharper end. And this works. I'm gonna actually use paint to illustrate, have a piece of wood handy to explain how this works.
And when
Is
you're holding up objects on these calls, you got to hold them up slightly longer than you think.
Oh, I see. Okay. Use my shirt. So there's a slightly there's a sharpened end to the hold down, and how this works. Oh, actually, sorry, I forgot that I'm sharing screen at the same time. Okay. So there's a sharpened end on this side of the clamp, and the way this one works is, once again, share screen. So I'm often surfacing the tops of pieces of lumber, but also doing two-sided machining. And so as much as I can, I try to protect the top face of my lumber. So what I do here is I will actually I'll rip a small groove into the piece of wood from the side there, right along the center. And run the narrow part of that sharpened clamp into that groove. And that allows me to keep the surface completely free for surfacing, as well as flip it over for two-sided machining. And that's been probably my favorite upgrade to date. And it's just so simple. I saw this on a very brilliant German engineer's YouTube channel, Marius Hornberger. He's great. If anyone's heard of him before,
How did you cut your slot?
right on the table saw. So you just rip it, you guide it right along the center of the table saw.
Another thing that works really good is a biscuit joiner.
Oh, this is
Pop a slot
yeah,
in there and you're done.
I do see what you mean.
And actually, with the biscuit joiner, if you sort of made a mistake and you needed that bit of wood there and you don't want to cut it off, you could always just knock another biscuit in there and sand it back, and you won't have the hole anymore.
Yeah.
Yep.
Yeah,
Pretty
thanks.
cool.
Thanks for that, guys.
Another thing to have a look for, it's more used with aluminium, brass, metal hold down. But look for toe clamps. There's a variety of toe clamps, which basically they will come down at a angle and they will push down on the material as you tighten it as well. So they're pretty good too.
Yeah.
Yeah. You also, like, you go to Harbor Freight or something and you can get a set of step blocks, clamping set up for maybe, I don't know. Let's call it $60. It may be less than that. But it's a whole set of different length steel step blocks that you use in machining. And you could use those on the CNC just as well. You just don't want to run your bit into them.
Exactly.
Yes.
I appreciate the insights, gentlemen.
I do have an off the wall question.
Sure.
Very specific. Does anybody explain a G93 inverse time code in G code? There are a few machines that on the rotary, they use a G93 inverse time command. it puts a different feed rate on every line. I'm thinking it's a throwback to the days before some of the more modern control systems. I cannot come up with a good reason as to why you would have variable feed rates on every line on rotary. Vectric, when they output for that type of G code, you dial in 200 inches per minute, and the output G code varies anywhere from 40 to 600. And it seems almost like it's a throwback to when the controllers were not adequately controlling the feed rate to match, the interpolated moves from X and Y.
According to Google, the G93 G code inverse time mode is used to program simultaneous coordinate, linear, and rotary motion, and it basically causes the F, which is the feed rate command, to cause a move to be completed in 1 divided by F.
You're reading out a
Yes.
CNC cookbook, huh?
I'm reading it off of Google. So
Okay.
yeah, so if F is 2,
No, if you
the
too.
move would be completed in 30 seconds. I have no idea why you would use that, but okay.
I have an 8-foot rotary on my shop bot with the Centroid, and the Centroid uses the G93. And probably 6 months ago, I made an effort to try to figure out what exactly inverse time mode is. And I think I almost got a handle on it, but I'm not sure. All I know is it uses it and it turns and it works. So that's my main interest.
I don't think it'll be a biggie for wood, but it'll be a biggie with metal, and I think it's probably more so used with lathes, etc., where you may do a tapered, where you're coming in for the cut on a round object. And what'll happen is if your lathe is spinning at so many revolutions per minute, the surface speed at, say, 4 inches diameter will be a lot faster than the surface speed at 3 inches diameter. So basically, as you cut out and generally, I was looking at a command, I haven't used it, but it was something when I was messing around with doing some CNC lathe work, you could actually apply that as the cutter goes out in diameter, that the speed of the that the job turns at also changes, so as that you're always maintaining the same cutting speed as you're going along. Was one of the, I don't know if it's the same command, but it was something that I was looking at that was being explained. I can't see it applying on flat surfaces as much though.
I think on the Centroid, it's only for the rotary. It's the only time that it's used. And I don't know about a different speed for every line, because I have not noticed that in files, and just watching the speed when I'm doing a rotary, which is not the most accurate way to figure that, but I haven't noticed anything like that.
Yeah, it was just a bizarre question that popped up this week as to, does it improve the cut or make it worse?
There's 2 references that I found. One is from Tormach and one is from Vectric in the Vectric forum. I put them both in the chat. If you want to look at the second one, maybe that'll make it muddier or clear it up. I don't know. It's not something I've ever used, G93,
Okay.
but sounds interesting. There's got to be a reason to use it.
Well, and some of the controllers don't support it. And it seems like the older ones do do it. I mean, like all this stuff, it's cyclic. It's great for a while and then it falls off. Then, oh, hey, we discovered something brand new that's old. Yeah. I was trying to get from somebody. I says, okay, I kind of know what it does, but what does it do to the cut? Because if this darn thing is slowing down on wood, if it's slowing down to less than 30 or 40 inches a minute, I'm going to start burning my cherry. And if I'm programming this
Sorry.
thing, and if this
That
thing
was
is
12-year-old Bill thinking. Go ahead.
oh yeah, okay. No, not that kind. And if you're clipping along it or you program it at 200 inches a minute, and I'm seeing numbers anywhere from 600 to down to 40 or 30, I'm going, wait a minute, something just don't seem right.
Now, one thing I do know, I'm assuming this is something to do with your rotary axis. Is that
Yes,
correct?
sir. Yes,
Yeah.
sir.
I know that when you're programming metal on a CNC lathe, for instance, that it will vary the speed of the cut as you approach the center. It speeds up. So by the time you're when you're doing a facing cut, for instance, on the end of a workpiece,
Right.
it starts out slow and then it gets really fast towards the end, and then it's done. I don't know if that's G93 doing that or
Yeah. Well, it's kind of like Ned was mentioning, that it could be more applicable to other types of milling. Because this thing, the test I did was just on a 4-inch round cylinder, the simulation, and then just a 1/8 inch deep cut of just various rectangles.
Yeah.
So nothing crazy for depth differential or anything. And these things were all over the map on feed rates.
Well, that
And
first,
wow, I've never seen this before.
well, that
I
first,
push my rotary a lot. I usually cut it with like a 1/2 inch cutter at about 360 inches. And with the invert time, which it always uses, it never slows down appreciably. Like you're talking about 30 or 40, it never slows down that much. And I don't remember, I checked it with a tachometer a week or so ago when I was doing something to see what the angular velocity was. And I don't know. I haven't seen what you're describing
mhm.
on mine, but I'm not a programmer and I'm not real interested in that aspect. So I don't.
That first thing that I posted in the comments had the actual math that you're supposed to be able to use to determine what's going to happen, but I don't know
Yeah.
where you'd be using it, so I don't know.
Yeah, I've seen that as well, that same reference point. Well, actually, both reference points. And both are the one was fairly dated, which led me to believe, okay, is this a holdover that that compensated for something else, since all the calculation is done within Vetri?
Hmm.
They're the ones who are creating these numbers based on some formulation, because it's not the controller doing it on your machine. It's just enabling that to be done. And I thought, okay, well, this is interesting. I grab onto something and I can't let go of it, so I'm curious.
Well, there's a discussion in the Master Cab forum about it, and
Metal work.
yeah, it's for metal. So
Yeah, I'm wondering if that isn't the more applicable avenue to that thing.
here's one statement it says is G93 was the original method of synchronizing linear motion with rotary motion. So
Right.
just because it's the original doesn't mean you need to use it anymore.
Well, yeah, because maybe technology has moved on, because on mine, I've got a pretty good speed machine. I can go to 2,500 inches a minute on a program. Doesn't mean it's going to get there.
Yeah.
Because it's still a coordinated move, but I can get it spinning at about 180 RPM. And it's still it cuts, if I want a square, it cuts a square. If I cut a spiral, it cuts a spiral. So it's still an interpolated move. And like we were talking one night, the Z1 and Z2 on the Safe Z and the material setup, I had contacted Vectric and I said, what's that second one for? I know the Safe Z is fine. Then you have another one down close. Why? Because this second one, or the first one is at the plunge, or the second one is at the plunge rate. So it goes quick and then slow down to the surface. Answer I got back was, well, some machines need to slow down so that they hit the target, and rather than overshooting. I go, are you telling me that you guys are making up for bad controllers? Well, we didn't say that. I go, yes, you did. I said, otherwise it would look like a woodpecker. And I said, so is this another holdover from when controllers weren't up to the speed they're up to today?
I think if you look at it, if we step away from the big cutters and let's move to a 1 or 2 millimeter cutter, and wood and plastic's very forgiving, and let's go back to the rotary. And if you've got a part that's steel and it's in a rotary chuck and it's spinning, so you're machining down here at 1 inch and you're moving at say 1 millimeter a second, and your cutter can handle that. But when you get up to 5 inches in diameter, because the machine is operating in radians, you will find that your 1 millimeter a second will turn into 5 millimeter a second, and you'll end up with a broken tool.
Yeah.
So
okay.
yeah. So, and that's obviously if you're pushing your machine for maximum performance, time is money type calculation. So you'd want a program that'll adjust on that. But if the tool was capable of cutting it, you just drive it through it simply. Yeah. If you can, yeah.
Yeah, I said it was an unusual question.
Yeah.
So let's put it out there to any of the listeners that are, seeing this show later. If you got some information on the G93 code that would help clear this up, let us know. Put a comment in the group. We'll be glad to listen.
Now, see, this was in a fairly new post processor from Avid. So it wasn't a dated thing. And, to everybody's good intentions, sometimes you grab an old version of stuff thinking it's still applicable to today's controllers. And maybe it is.
Speaking of Avid, I just noticed something in the news feed the other day that Avid is now switching to Centroid as their controller of choice for their built up machines.
I've heard that as well.
Yeah, so that's quite a coup for Centroid. Probably going to simplify the design of that box with less components by doing that, my opinion. But
seems like Centroid is being encouraged to improve product. I've heard several good things about it.
Yeah. So I like the one I have, and I actually have 2 of them. One is waiting on me to upgrade my router. So we'll let you know how that goes when my spindle gets here.
I think Centroid also supports G93.
Yes, they do.
Oh yeah, you already said that. I'm sorry.
Yeah. And my assumption from Gary Campbell is that you have to use inverse mode with rotary, but like I say, I'm not a software guy, so.
Yeah, see, on my particular rotary, the control system doesn't even support G93, but it works for everything I've ever tried to do on it. So it's just, like you said, probably just a different approach.
I'm not going to throw shade. Because you said, oh, is this or something they're making up for a bad controller? And you said yours doesn't support it. So I was.
Yeah. Well, and I was reading in there that it's, they've got other ones in here. What is it? G94 and G95 are kind of in the same category. And one is in feed rate units per minute. and feed rate units per revolution. So are those the migration to where they went to?
Mhm.
And if you no longer need to use G93, why would you support it to add confusion to the program G-code output? Things that you go, what? Don't know. If G93 is better, then why wouldn't some of these controllers say, okay, that's the way to go, period? You know, and then we're talking about G code that started back in the 50s.
Yeah. But the problem is it becomes subjective. A guy says, well, I was going to buy your product, but you don't support G93. You know, or you only support G95, or you don't support, you know,
Oh yeah.
and then so you throw that sucker in there and let them, you know, let them choose. But I don't know.
Then you found out that somebody put it in there because, well, that's what everybody did.
It's always been there. Yeah.
Yeah, the standard answer.
Yeah.
But rotary is kind of a stepchild, I think, to almost all of the routers. And so, you know, I don't think they give it the level of study and concern that they do on other things.
Nope. There isn't near the audience, I don't think. It's coming along, you know, because some of the spindles that I've done, there's certainly money in it. You know, so until it's all money driven. I mean, we all do everything we do usually for some kind of compensation.
I find that hard to believe. I do it for the love of it.
Only if you can afford the equipment.
I tell you, it feels like it's for the love of it sometimes. I was actually hoping that the lady that was on the forum, I think it was Helen, she did a response to your CNC router post earlier on, and she has done a lot of 3D carvings, and it looks like she sells them. And I was going to ask her, how is she doing making money on those? Is it for the love of it, or is it actually for profit?
Well, trying to get efficient at some of that stuff. I mean, I've seen some people where they put settings that are so far out, they would make far more money down at the fast food restaurant.
Yeah.
You know, and wood, you don't need a 0.5 millimeter tipped bit to get satisfactory detail. Metal, different animal. You know, but some people just go over the top or are going so slow, well, you're never going to make any money anyway.
Actually, my correction, guys. Sorry, Nadim, that was you. I thought it was a female name. Sorry, Nadim. Are you there?
What was the example that you mentioned?
I was having a look at your Facebook profile, and I noticed that you did a hell of a lot of those 3D carvings, and it looks like there's many hours of 3D carvings you've done there. Do you sell those, or do you just do them as gifts, or how are you making money with those?
I'm sorry, man. I don't know who you had seen. I don't really do the 3D carvings.
Oh, hang on. Oh, hang on. Hang on.
It's entirely okay.
Hang on a second. I'm sure that was you. Hang on a second. I'm just going to go and have a look.
But you did get my name right, though.
It might have been. I thought it was no. I thought it was you. Actually,
Maybe it was. Anyway, I remember when I was working on my my router, I designed the warp drive project because 3D carvings were so slow. I wanted fast ZX. Router design the warp. One more time. Slow. I wanted fast ZX. Oh, somebody's got their speaker on. That's what I'm hearing in the background. Okay.
I think Ned is trying to find the.
Oh, so no, I don't have anything playing in the background. Everything's quiet over here. Oh, so no, I don't have anything playing in the background. Everything's quiet over here. Oh, so no, I don't have anything playing in the background. That's not me. That's not me. That's not me. That's not me. Or is it? Hang on. Hang on. That's not me. That's not me. Or is it?
There it stopped.
Yeah. And
Does anybody make money with 3D carvings? It doesn't interest me, but my rotary, okay, I've been a furniture maker for 45 years, and a good part of my business was churches, building altars and things. And with candle stands, I made a lot of money off of my rotary because I could do different shapes and spirals, and churches would pay 3 times for a spiral over the same candle stand that had a straight shaft, and the machine didn't really give a damn where it was, what it was doing. But I don't know how people make money on 3D carving. I suspect they really don't.
Well, on my latest machine with the current controller, I programmed it to cut 3D at 600 inches a minute. And then I videoed the running feed rate.
Mhm.
And yeah, it's all over the place, but in the straighter, shallower, dished areas, it would hit 600. And you know, because I set the Z at 400. And I think what Bill was kind of alluding to earlier, that yeah, you can only max out, but if the Z isn't moving very much, then you can flat get to clipping.
yeah. Yep.
And we just cut, well, basically the texture of your hand, and that took about 25 minutes of a normal hand size. Depends on the application. Yeah. Now 4-foot square taking 24 hours, it's probably somebody you love.
Yeah.
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 But I at the same rate, I do know a guy that cuts door inserts, you know, for the center panel of a door. Very expensive doors. And wildlife scenes and all that. Then, yep, you're not selling that to extreme low income folks. You know,
Many times you have to find the right client for your projects, and that takes that takes some doing, because if you're trying to sell that expensive door panel to somebody who is making $15 an hour at McDonald's, it's probably a bad fit
yeah.
uh, for you in the first place. And so you might want to sell that panel to the guy who owns 5 McDonald's restaurants, instead. But that's not the ultimate answer. The problem I found with the 3D was that the machine is waiting on the Z-axis.
Yep.
Always, because the Z-axis has the smallest travel distance, and so anytime it makes a change, it happens very fast. And so if your acceleration and deceleration isn't set right, it never can get up to the top speed that you program it for. And so part of the warp drive project was to tackle that, and it did a wonderful job. And I made a few 3D pieces after I did it. And now, because I'm of the way I'm wired, that problem was solved in my head, and I moved on. I sold the plans to others who wanted to go down that road, but then I was moving on to something else. It's just,
Yeah, like I said, it's very specialized, but like on those candlesticks, yeah, I seen one pattern. It's actually on the Vetric forum, or on the Vetric free projects. Nice candlestick, but the trouble is, it was all 3D cut.
Yeah.
It took over 3.5 hours.
Yeah.
And then, okay, there's no money there. Well, then if you use a shaped bit, you're talking less than 20 minutes. That's if you're kind of slow. You know, so it, yeah, the proper bit for the proper job at hand, you can turn out some great stuff. Bunch of barley twist ballisters. I'll do that job again.
I haven't seen this available, and it probably is. If you know, let me know. But when you have a shaper, like a shaper table, a router table, shaper, bigger, heavier duty thing, you can buy custom cut knives to different profiles
Yep.
to give you different shapes. But I haven't seen the same thing for router bit, custom profile router bits. Has anyone
yeah.
seen that?
Oh,
Yep.
yeah, you get a router bit made whatever shape you want.
Where?
Magnate is one of them.
I haven't had one made in a while, like 4 or 5 or more years, but if you Google it, for custom router bits, you can find people, yeah.
Yeah, magnate.net.
That's not an unusual thing.
Yeah, I've used Magnate's surfacing bit, and I used a couple of their V bits. They're good bits. I didn't know that they were doing custom.
Yep, they'll do custom, and they're fairly, I mean, they're reasonable. It costs you about the price of 10 bits. Well, you have them make 10 bits, and they're about the same as the rest of them. And those guys are good enough to where they're going to say, hey, we might be able to add this to our catalog.
Yeah.
You know, for like a lamb's tongue, most everybody uses a doggone V-bit and does a make-believe lamb's tongue. I mean, if you do any wood turning, you know what a lamb's tongue looks like. It's a very distinct shape. Well, I designed a bit to do that. You know, you're done in just a couple seconds. And I haven't had it made yet, but yeah, that's a good thing about Vectric. You can design your bit, do the test cut, see what it's going to look like, see if you like the output in the simulation, and it works extremely well. And then you can take that design, send it off to these guys, say, hey, I want that bit made. I've known people to use them to create specific bits for a specific job.
Oh, very good. Thank you. I'm glad I asked the question. One thing that didn't get mentioned in all this work holding is the plastic nail guns.
Brad nails, yeah.
Yeah, plastic brad nails. There was originally one company that made them, but now there are several. They tend to be expensive for the nail gun, and you can't just put the plastic brads into a regular nail gun. But
I have seen one and shot it and looked at it and worked with it a little bit. Wouldn't be my first choice. I mean, you get very hard wood and it doesn't like that very well. And then you got to deal with the porcupine effect of your spoil board that you poked it into. And, you know, yes, you can surface it, but you don't want to surface it after every job either. And then because they break off. And now you got these little porcupine things sticking up everywhere and you're going, oh crap. So now you got to deal with those. It seemed like a good idea. I'm not a really big fan, but I'm sure you'll find somebody that'll swear by them where I'm swearing at them.
I was actually, I found one company in Australia that's doing them. And now that I've heard that you need a specific brad nail gun for it, I'm glad I didn't go to buy them because they're not very cheap. They're quite expensive. And now that I've heard that they're not that fantastic at holding down, I might give them a skip.
Well, they hold down well.
Yeah.
But it's got to come up.
Okay. It's got to come up, right? Yeah.
Well, and the funniest part is sometimes it's easier to hit the side of it and break them than it is to pull them up because they shear with enough effort, but they always leave a sharp fragment. You
Okay.
you don't rub your hand across the top. Or you get a hand plane that you don't really care about your blade a whole lot. And plane them down flat. There ain't a perfect answer for a hold
Okay.
down. Everybody keeps searching for the perfect answer, and I haven't seen one yet.
Yeah. Now you have to be diverse in the hold down. There's specific hold downs that'll work, and then there's ones that'll create more of a problem.
Well, it's like that T-track. I wouldn't even think of putting down a T-track unless I bolt it down with T-nuts underneath.
That's how I did mine.
Yeah, because a lot of people use the screws into MDF. You're screwing into sawdust. Give me a break. It's not going to hold.
Mm.
Yeah, no,
They said, well, we'll put a little super glue down. You're still gluing to sawdust.
we used T-nuts and the bottom surface of the spoil board came up through the bottom and drilled. I can't remember if we drilled and tapped, and it's been too long. The 80-20, and that held it down. It hasn't budged in years, and
I clamped the daylights out of my stuff because I've had it move before.
mhm,
It's not going to move again.
yeah.
So I put on more pressure than necessary, but by gosh, it doesn't move.
One one trick that we did with the 80-20 T-track, I was using the economy T-nuts, which are just the flat piece of metal with the tapped hole in the center boss. Those don't just slip in like somebody was describing, the other T-nuts. 80-20's got a whole bunch of T-nuts, but these are the cheapest ones. Anyway, what we did was we machined into the track in a couple of spots an oval shape that would just fit a nut.
Yep.
And so rather than having to slide one from all the way from the end down the table, there were a couple of spots in, we could just drop a nut in there and, tighten from there. And it didn't really affect the T-track or anything. It, didn't bind or slowed it down or anything. It's just that, if you get in that one spot, there's not enough rail there to clamp down, and you just move it over a little bit.
Yeah.
A cheap source for some nuts that you can use for T-nuts that I've used is, do you guys have a thing called Dexion shelving? Metal, like the metal office shelving and stuff like that you screw together?
I don't think by that name.
Okay, might be a different. What they are is they're just a really cheap. I think there's two sizes, 1/4 and 5/16 or something like that. And they're just a galvanized bolt with a square nut that's been cut out of a bit of flat bar, galvanized square nut that's been cut out of a bit of flat bar. And they sell it at the, over here, they sell it at the hardware stores. And it's just, they're sort of like two flat panels, and they just got holes stamped all the way down the side. And then you put a metal shelf into it and then bolt it together. That's what they use them on. They're really common and cheap. And those nuts will fit into common sizes of the T-track. So if you need a cheap nut to use, and the actual bolt itself works on it as well, I use it to hold down the MDF. I just slide it in.
Okay, yeah, DEXION North America.com. That's our local version of that. It's basically keyhole slots, basically.
That's it.
Yep. Okay. Yeah. Cool. Google's such a wonderful tool.
I've
Have a good one, Wayne.
See you later. I've posted a picture of a non-profit 3D carving.
That's pretty good size.
It's a huge. That was for the guy that owns a business. That was for his wife. So
that's that honey thing.
Mm-hmm. Yeah, there is no profit in the Last Supper.
As a no profit. That's it. Yeah.
Yeah. Mm,
It looks
Yeah.
about what, almost 18 by 36.
I'll believe you.
yeah.
It was pretty wide. Yeah.
What was that, 24, 28 hours kind of thing or something?
Oh, look, I just programmed it, set it up, and he actually did 3 of them because other family members other family members wanted them as well. So yeah.
What type
Mm.
of wood is that?
I think that was white European oak.
Oh, okay. It almost looked like a pine type of wood. I go, no, you wouldn't have cut that out of pine.
No, it's a hardwood. He does a lot of stuff out of white European oak, so I think that's what it was off the top of my head.
I always wondered why whoever designed this Last Supper thing put in all these spades and hearts and things on in the background.
Maybe
Yeah.
just to fill the textures, but as you were saying, it's the Z height and those little hearts and that they really add to the time.
Yeah. Yeah. If you could do a roughing to remove the majority of the airspace behind the behind the banquet table there, that would really help, but there's a lot of cutting time here.
Oh, yeah.
What I did to increase the time on that is I actually isolated the heads and the hands.
Mhm.
And the faces and the hands were done with a 1 millimeter ball nose, and the rest of it was done, and the toes, just more so where you needed the detail, where I saw that it was detail. So I did those areas with a 1 millimeter ball nose, and the rest of it was done with a 3 millimeter ball nose. So that dramatically improved the time it took to machine it.
Mhm.
I was not aware that you can isolate parts of a 3D carve. Where can one go to learn about this? Like, do you have any favorite
We do it
YouTube
all the
channels?
time. Yeah.
What software are you using?
A Vectric Aspire.
Bill's your man.
Bill.
Draw a
Okay.
vector.
Good to know. Thank you.
Yeah.
Just draw a vector and cut inside the selected vector.
Mm.
Yep. Yep. And you can do each head as a selected vector, and it will spit out a toolpath for each head. So you have pick an apostle, and it would do their head.
But mind you, it was faster. I didn't say it was fast.
Yes, understood.
It's relative.
I'm fascinated by the fact that that's something you can do at all.
Yeah.
Oh yeah.
So if you like import the 3D model or I guess you would call it a model. What's the process of isolating that part? Is it draw a rectangle and select the content inside that rectangle, or?
Mm-hmm. Yeah, there's a bounding box tool too as well, and that it'll do like a rubber band around a selected area, and then you could. Short answer is draw yourself an ellipse around the head and call it a
Can
day.
you do like
Okay.
polygon lines in Vectric? Can you do like a
Yeah.
curved or polygon
Yes.
line? So it
Yep.
doesn't have to be a square or an oval. It can actually be a tight hugging profile around it.
Yep. You could node edit the vector
yes.
to get it closer, and but now you're spending more design time, not necessarily more cutting time. The trade-off.
Yeah.
Mhm.
I'll pop something up here that's got some detail to it, maybe.
Here, I will stop sharing.
All right, thanks, guys.
Yeah.
And then I will, okay, hopefully I don't lock up the system again. Let's just say you wanted to
Mhm.
do it right here. Come on. Then when you do your finished toolpath,
Wow.
whoops, I hit the wrong button, obviously. Oh, it's mad at me. There we go. Close enough.
But if you're
Down
doing
here, then it
Sorry.
says right here, selected vector.
Mm-hmm.
And now you're restricting it to just that section.
Awesome. Thank you guys.
But just keep in mind, if you're leaving, like if you're using the ellipse like that, and in that darker shaded area above the eye, you got to make sure your tool 0 is pretty precise.
Yes.
Otherwise, you will see the step. So yeah, it comes down to finishing sanding or getting the tool heights absolutely correct, or doing the node editing your vector so it
Mhm.
hugs closely to the edge.
Yeah, the other thing that I've done is match your larger bit in this restricted area and put that in here as well, plus the smaller one. And then when it creates those tool paths, don't cut the big one. Just cut the rest machining section that the bigger bit didn't get.
Mm-hmm.
Because like right now, I've got 3 different bits listed here. Let's say this 1/8 inch bit was the roughing bit, and these other 2 are now going to be the rust machining. Don't cut the one that already roughed everything out for you or did the majority of it. Do just the 2 tool paths on the fine stuff.
Yep.
And it works very well.
The other thing, I wouldn't do this type of work without using some sort of touch plate or tool length measuring device. So without it, you can't get the repeatability you need to make this look seamless. And you're doing what Ned was mentioning earlier. You end up sanding a lot to try and make it work. But if you're using something like shameless plug, a triple edge finder, just
You know a guy.
no guy. To set your Z axis for your bits, then it's going to be within well within the machining parameters of wood. We're having a different conversation if this is metal.
Metal is more precise.
Yeah, metal needs to be much more precise than wood. With wood, you can breathe on it and it changes dimension. Literally from the moisture.
You don't even have to touch it. You walk away for an hour and the height's changed.
Yeah.
Somebody asked me how to prevent that. And I said, plastic.
Yeah.
Well, you could use a vacuum chamber and put your whole machine into a vacuum chamber and hope.
And stabilize it in epoxy resin.
Actually, no, that's not a joke. The way that you prevent that, and that's from your timber bowing and warping, if you walk away or if you're coming back the next day, is put a cover sheet over it if it's on your machine. Even if you walk away for half an hour, I go for lunch or something like that, and I'll just throw a 3mm or something cover sheet over the top of it so the humidity and the moisture in the air doesn't settle on it, and that will bow and change the heights.
All right.
Yeah, and I tend to, when I've got a project that's going to be 3D cut, I will plane the top surface, or excuse me, it's actually the bottom surface of the material, flip it over, and then plane the top as well. Now both sides are open. The one on the bottom is not going to get quite as much air as the one on the top, but it's getting some air.
Especially if you have T-tracks.
Yeah, so it's gonna warp a lot less aggressive. But all wood warped. And
a tip to straighten it afterwards, you're going to laugh at how simple this is, and you could also simulate this with a bit of wet rag or something like that, is if your wood bows like that, what you do is take it outside, flip it over and put it on some cold grass on a sunny day, and you watch it straighten within 15 or 20 minutes.
Cool. All right.
But after that, seal it and oil it, otherwise it'll bend again.
Yeah, I've always seen it. It always cups to the cut.
Yeah.
It never cups away from the cut. I even thought about doing glue ups the wrong way. You know, where you always flip every other one. I was thinking about, okay, have all the crowns up so that it would want to warp and then cut it the other way. And maybe the tool will cancel each other out. I haven't tried it yet, but I don't think it's predictable.
Timber is a miserable thing to work with.
Yep, I always told one guy, I said, well, you could screw angle iron to the back of it.
Well, actually, now that you've said that, I've been holding a piece here just more so to retouch on how effective the masking tape, painter's tape method is. And now that you said tape some, screw some angle to it, I'll just turn my blurriness off. Actually, I'll share a photo. Let me just open it. Where it's gone. Here we go. And now share. Because if I open it up before I share it, after I share it, it doesn't show. So, okay, so what you're looking at is that's a cross pendant I've made, but it's that little brass ring that the chain goes through. I needed some of those. Now I know what they're called, and you can buy them so cheap and so easily, but they're still not very strong, the ones that you buy. They're very flimsy. So I had to cut some out of brass. So now I'll stop sharing now. So what I've done is I'm a hoarder and a half. Any bit of scrap metal, I turn this
blurry off. Yeah.
So any bit of scrap metal that I get, and this goes in the doors. So some of the doors that I program for a guy, they're like $5,000 to $10,000 a door, and there's some really expensive stuff that goes into it. And when they glue it up, they will actually put lengths of this aluminium through it to stop it from curving, bending, warping, because these doors are sometimes about 2.5, 3, like whatever the full height of the ceiling is, they'll be full height doors, etc. But what I did was I've drilled some holes into the aluminium just to reuse the scrap, some holes in the back, and I will just screw that down to an MDF hold down, or if they go onto my aluminium bed on the machine, some double-sided tape, and then I'll double-sided tape a piece of brass onto it. And if you can see there in front of my nail, there's one of those little pins. And that's been CNC'd. Nothing spectacular on the hold down, but that's been CNC'd with a 2mm end mill to create those little brass, pins, etc. And that was just out of one sheet, and that was with double-sided tape, and it holds it down really, really well. So double-sided tape on the back of the brass, double-sided tape on the aluminium, super glue in between. Nothing but the finest super glue. I get around about 5 or 6 tubes for $1.75 in a cheap no-name pack. Works fine, and that's it. And yeah, it holds it down really well. That's how tiny you can go, and that's out of 1.6 mil, or what that'd be around about what's a 1/8 thickness. Yeah.
Now, could you tell us the name of that metal that you're holding, the silvery one? What is that?
That's just aluminum. Aluminum.
That's just like that axis that goes up and down.
Yeah. the Z or the Z. Yeah.
First time I heard Z, I had no idea what they were referring to.
Yeah. Oh, the only thing that separates us is our common language.
Yeah, the what is it when you go in to install Microsoft Windows? The 20 or 30 different versions of English.
Yeah. Yeah. Over here, go down to southern Louisiana. Even on the television shows, they have to have subtitles.
Y'all going down there.
Oh, I tell you what, some of the folks in the bayou. Oh boy.
Oh yeah. Where was that movie? The Water Boy.
The only way that I know that is, I think was it Kamala Harris went and did a speech there, and they were taking the piss out of her because all of a sudden she got a Southern accent.
Yeah. Yep. Every politician.
Yeah.
It's funny. I've seen people just pick up the yeah. I'm trying to find the right word for it. They literally absorb the accent of the person they were talking to.
Yeah.
The Canadian guy was speaking to an English guy. All of a sudden, the English in him came out for spontaneously. It was bizarre and fascinating.
Well,
I find the South African English to be the most fascinating to listen to.
Yeah.
yes. Yeah. When I visit relatives in the South, you just talk differently than you do on a normal basis. And regardless of whatever I say, I've been described as talking proper because I can't, I can't quite get there. Even, try as I might. But, yeah. This is what the result of being raised in upstate New York is. This is the way I speak.
Even in North Dakota, you got to get the
Yeah.
O in there.
Yeah. Well, you go out to different parts of New York, and for instance, on Long Island, they speak differently,
Yeah.
so it's just different,
What was the name of the first gentleman who was presenting today? Definitely a New Yorker accent. Am I wrong? Michael. Yeah.
Yeah,
Michael,
Mike.
go.
Yeah. Oh, yeah. I think Mike said that he was from Long Island as well. But I know he's from New York. Whether
Mhm.
it's New York City, and Long Island aren't considered the same if you live there. But I think he's originally.
I know the Boston vernacular is definitely
Boston.
different. Coffee.
Coffee.
Got to park your car.
Yeah, Mike Bernascoli, I think I pronounced that correctly, is from Massachusetts. Like that, he has that Mass accent. Yeah.
Boston would be a heavy Italian or something, wouldn't it?
Depends on which neighborhood, because there's a lot of Irish people there as well, and there's a lot of English, and you name it. Yeah. Yeah. So
Well, gentlemen, it's been a pleasure. I'm going to have to step out.
yeah, I was about to close down for the day because I think 2.5 hours is plenty to upload to YouTube.
That was solid.
Yeah. Thank you all for taking on the topic tonight, work holding. And I will load this up on YouTube so folks can enjoy it in the future.
Yeah. Much appreciate all the old guard pro tips being shared as well. Thanks, guys.
Where's the old people?
Yeah, where?
I definitely felt like the baby only started my grace.
Mhm. Well, we do this every Wednesday at 7 p.m. Eastern time, inside the CNC Router Tips group, and we hope you can join us next time. Thank you, everyone.
I've been in this
Hey,
group for
guys.
years, and
Bye.
for some reason, Facebook decided just today to show me that post.
It's funny, and I'll tell you the reason. Facebook, there's 21,000 members in the group. If I say, hey, at everyone, we're going to meet tonight, Facebook will put that out to maybe 200 people.
200-ish, yeah.
So don't be surprised you haven't seen it.
Mm-hmm.
Just the way that they do it.
Just a little tip there. One of the other things, Bill puts the link up for the Zoom at the last minute due to Facebook issues. But one of the things that was causing all that echoing earlier on, Bill, is I went to the just to the main page of the Facebook group and scrolled down, and it straight away opened and streamed the YouTube video. And I didn't realize it was in the bottom right-hand corner. So that's what was causing the echoing. So maybe there might be a setting for that. or that's going to be too hard. Yeah.
I wish there were. All right.
See you later,
Thank you.
guys.
Thank you,
All
Ned.
right,
Thank
farewell,
you,
friends.
everyone. Thank you.
See yous.
Bye-bye.
Have a great one.